Hello, we are here again with another lesson on organic production course. In this lecture we will deal with soil fertility management. Three main issues will be presented and discussed in this lesson. First, as usually, we start with concepts and some definitions that are important to continue further. Always these concepts here deals with the soil and soil fertility. And then we will speak about soil fertility, how to assess it, how to measure the soil fertility, which are the indicators of a fertile soil, and then we'll speak about how to manage the soil fertility in agriculture. So let's start with the first concepts and definitions. Let's start with the soil definition. Soil is a mixture of organic matter, minerals, gases, liquids, and organisms that together support life. All these elements can be grouped in two main groups: inorganic materials, which includes minerals, water, and gases, and organic, which includes organic matter, the dyed organic matter, and living organisms. And the living organisms you have mainly arthropods and microorganisms. So let's speak about main soil components now in figures, in numbers. So minerals assume to be about 40 to 60% of the soil, water 20 to 50%, air 5 to 10%, and organic matter 1.5%. But why soil is important? Which are the functions of the soils? Soils are an important material that support roots. In this case, help them to stay upright and to grow. The soil provides plants with essential minerals and nutrients. It provides air for gaseous exchange between roots and atmosphere. Soils protect plants from erosion and other destructive physical, biological, and chemical activity. Soil is a material that holds water, so create moisture, and in this case, maintain adequate aeration for the plant roots. How can we distinguish different soils? Are the soils all the same or they are different? In fact, the soils are, we can find differences of the soil from place to place. Even a small area, we can find many changes or differences in the soil characteristics or properties. For this reason, we have to know these properties in order to assess different soils and based on that, to assess if soil is suitable or not suitable for a species of plant. The soil properties for uh, simplicity, in order to simplify the assessment and evaluation, it is assessed based on three groups of characteristics. So, the properties of the soils, that is a list, but it is grouped in three main groups of soil properties. One is soil physical properties, two is soil chemical properties, and the third is soil biological properties. Which are the soil physical properties? The soil physical properties are horizonation, soil color, soil texture, its structure, and bulk density. Speaking about soil chemical properties, we can speak about cation exchange capacity, mineral content, salt content, soil reaction or pH, and carbon content that is very linked to organic matter. What about biological properties? The important biological properties of the soil are mentioned three properties: soil biodiversity, the presence of plenty of beneficial organisms, and low pest pressure. These are the biological properties of a good soil. Here you see a photo. That is a photo of soil profile. But what is a soil profile? A soil profile is not other thing than different layers of the soil that are in the vertical profile. These layers of the soil are visible even by free eye. They are typically parallel with the ground surface. Here you have the example of a deep soil where you see most of the horizons of soil profile. So if we see from up down, we'll start with the first layer, or the first horizon, that is made of decomposed and some undecomposed materials. Here the organic matter content is very high and the biological activity is very intense. Then go to the other layer or to other horizon. We have the horizon A. In fact, it is called topsoil. In this horizon, which has dark color, has high content of organic matter compared to the other layers that will come deeper. Usually, this topsoil is the most important soil where the roots find their nutrients. Then comes horizon B, which is a zone of accumulation of fine minerals and mineral precipitates that comes from the upper layers through the water that moves from up down. Here in this horizon, there is higher content of clay, carbonates, iron, gypsum, and so on. It is called subsoil. And then comes the horizon C, which is partly weathered rock. Here, the rock is not transformed totally to soil. It shows the origin of the soil from rock, and here we find rock fragments of pieces of different sizes. And then the last horizon is called rock or mother rock or hard bedrock. It is a rock layer which is not altered yet. Here you have again a photo that is showing what um, I explained in the previous slide. Here you have a photo of a profile, but it is not at all like the soil profile that we saw previously, because this is the profile of very shallow soil, where here you don't find uh, all the layers of the profile that we saw previously. So you see a very shallow soil, which is subsoil, and it is missing even here, it is missing the O or zero horizon. And we have here even not well, how to say, well distinguishable or not well present the A horizon. And then we go directly to the rock. You see the stones, which are the mother rock or the bedrock of the soil. And contrary to the previous photo, here there is the photo of a soil profile in a deep soil. As you see, the soil here is deep till 2 meters. That is not always usual to other soils. In the next part, we will continue again with the soil fertility properties, and exactly we'll continue to speak about soil color, which is very linked sometimes not only with the origin, with the origin rock, but with all the processes of soil formation. And it is one of the even indicators for classification of the soils. Till the next time, have a nice time and good study.